Geometry Geniuses. This is Mrs. Long, and we have just finished up with IA4, and the teachers and I all got together for day-to-day, and we saw that there was one problem in particular that a lot of folks missed, so I wanted to help clarify some of the questions we had about that. What we need to do is we need to figure out what relationship is there when we have similar figures. What is the relationship in their area? Okay, and I'm just tilting it up here a little bit so that there's not such a glare. So if I have similar figures, well, wait a minute, what are similar figures? Remember that similar figures have the same angle measurements, but they're a different size, okay? And their sizes change in proportion to one another, and that proportion is called a scale factor. So let's take a look at that. I'm going to use my handy-dandy knee of my jeans eraser here, which you probably saw there. All right, so now I'm going to create some similar figures for us. And you probably haven't seen anything like this since you were in elementary school, but you know how I love to have toys. Okay, so let's say I've got a rectangle, and my rectangle is a 2 by 3 rectangle. So here I am creating a rectangle. All right. And what I first notice about this rectangle, let me see if I have a red pen to go with it, is that the length of this side is 2 units, or 2 cubes. The length of this side is 3 cubes. Okay? Now, we also know that when we have rectangles, opposite sides are congruent. So if this side is 3, this side is also 3. And we know that if this side is 2, then this side over here has to be 2. Okay, everybody with me so far? Now, check out what I'm going to do. I am going to use a scale factor of 1 to 2. So I'm going to say the scale factor is 1 to 2. So I want to make a rectangle over here where its dimensions are twice as long, okay? So if this side is 2, if I multiply that by the scale factor of 2, then now that side's going to be 4. So I'm going to make 1, 2, 3, 4. Okay? All right. Now, this side is 3. Remember, I want to use my scale factor of 2, so I'm going to double the length of this side. So now this side will be 6. See if I have enough. So 1, 2, 3, 4, 5, and 6. All right, so now I'm just going to use some random cubes here to fill that in. I wish I had enough of all one color so you could see it that way, but I don't. So we'll just make do with what we have here. All right, so does everybody see what happened there? I used a scale factor of 2, so I doubled the length and I doubled the width. Ooh, that doesn't look so pretty, does it? Let me try that again. Let's see if that looks any better. All right, so I doubled the width and I doubled the length. So let me grab a marker there. So to double this side, it became 4 blocks. And I doubled this side, so it became 6. So this over here is 4, and this up here is 6. All right, everybody cool so far? All right, so I know the scale factor, and I'm just going to write it again down here. I'm going to erase it up here because it's kind of in the way here. The scale factor between these two similar figures is 1 to 2. Okay? So now what I want to do is I'm going to find the perimeter of this figure here. So who remembers how to find perimeter? Yeah, of course you do. We're just going to add up the length of the sides. We're just measuring the distance around. Okay, so I'm going to say 2 plus 3 plus 2 plus 3, and I get 10. And I'm going to say it's 10 cubes. Okay, well, let's say 10 units. Let's call it units. Okay, so the perimeter, or the distance around this, I can take a string and wrap it around it, And if I straighten that string back out, it would be 10 units long. All right, now let's find the perimeter of the other figure. This guy over here, the perimeter, or the distance around. And again, I'm going to do the exact same thing. I'm going to add up all four sides. So I get 4 plus 6 plus 4 plus 6. And when I do that, I get 20 units. Okay, everybody cool so far? So what I'm going to do now is I want to compare those. I want to compare the perimeter. And so the perimeter is 10 to 20. That's the ratio. Can that be simplified at all? Can we simplify ratios? Yeah, of course. We do it just like we do a fraction. So I look for a common factor. And I notice that 10 can be divided into 10, and it can also be divided into 20. So I end up with a scale factor, the ratio of the perimeters is 1 to 2, just like my scale factor. Pretty cool, huh? So if they said compare the ratios of the perimeters of these two figures, if the scale factor is 1 to 2, well, you would say that the ratio of the perimeters is also 1 to 2. All right, let's take that a step further. Let's look at area. Now we know that area equals length times width. All right, so now we've got two dimensions. With perimeter, we're really only measuring one dimension. It's a straight line distance, because remember, I can take that string, stretch it out, and all I'm measuring is length. Well, now with area, I'm measuring length and width. All right, so here, my length and width, it doesn't matter which one I call which. I'll say it's 2 times 3. And I find that I have 6 units squared or square units. So I'm going to write it as units squared. Okay? Now, I want to compare that to the area of this rectangle over here because they're similar figures. And I want to see if there's any kind of relationship there. So over here, I'm going to say that the area equals length times width again. Only this time, my length and width are 4 and 6. So that's going to give me 24 units squared. All right, I'm trying to keep an eye on my clock too. This kind of video only goes for 15 minutes, so I was keeping an eye on it there. All right, so here we have scale factor. Here we have the ratio of the perimeter, or we compare the two perimeters. All right, and now I want to find the ratio of the areas. Ratio of the areas. All right, and I found on this one that the area is 6 square units. On this one, I find that it is 24 units squared, or square units. All right, so again, I want to simplify. So to simplify that, I'm going to see if there's any common factors. And 6 and 24 are both divisible by 6. So I find that the ratio of the areas is 1 to 8. I'm sorry, 1 to 6 times 4 is 24. So 1 to 4. My bad. Okay? So the ratio here is 1 to 4. Well, how in the world does that relate to the scale factor and the ratio of the perimeters? Well, do you remember how we said that perimeter is a straight line distance? All we're measuring is the length. And we said that area is length times width. So we've got two dimensions, and it's measured in square units. So guess what? To find the ratio of the areas of any similar figures, we simply square the scale factor. So the scale factor squared, and I wish I had a little more room to write this, but if I took the scale factor, I'll tell you what, I'm going to get rid of these for just a minute. So if I took the scale factor of 1 to 2, and I squared it, I would get 1 squared compared to 2 squared. And of course, we know that when we square something, that's saying that number times itself. So I get 1 times 1 is 1, and 2 times 2 is 4. So that's how we found the ratio of the areas of those two similar figures. Okay? Now, if you're still scratching your head, I want to show you another sample problem. I'm going to use my fancy me eraser here. Whoop! Oops. Need a little more knee erasing here. Here's the fancy stuff. All right. So let's say they tell us, this is the way you'll see problems most often. They might say to us that the ratio of the perimeter, I guess I should say perimeters, of two similar rectangles is 3 to 4. All right, now they haven't asked me a question yet, so let's think for just a minute. What kinds of questions could they ask me here? If they gave me the perimeters, the ratio of the perimeters of two similar rectangles, they could ask me for the scale factor, couldn't they? So what would the scale factor here be? Well, we know that the scale factor and the ratio of perimeters is the same. So the scale factor would also be 3 to 4. All right, and then we said the ratio of the perimeters equals the same thing. But what if they asked me for the ratio of the areas? Then what are we doing? What if they asked me for the ratio of the areas? Well, how do we find that? Remember, we square the scale factor or square the ratio of the perimeters. Since they're both the same, it doesn't matter. So I'm going to say 3 squared as it's related to 4 squared. Now, how would I put that in my calculator? I would say 3 times 3 is 9. 4 times 4 is 16. So the ratio of the areas would be 9 to 16 because I had to square the scale factor. All right, peeps, I hope that helps. What you've learned here is that when you have a scale factor, the ratio of the perimeters is the same as the scale factor, but the ratio of the areas is the square of the scale factor. All right, I hope that was helpful to you, and I will see you in our next video.